Welcome students. This is a video that will explain a little bit more about simplifying polynomial expressions. We took notes on this information yesterday in class, and we're going to start our worksheet today. The problems that we'll do today off the worksheet are problems 2, 4, and 7. I think they're very representative of some of the harder ones on here. First of all, let's read the directions. Simplify each polynomial by using the distributive property, and remember the distributive property is where we take the outside monomial and multiply it to each term of the polynomial in the larger parentheses. And the property of multiplying like bases. Now remember, when we multiply a like base, if I take x squared times x squared, I add the exponents. So that'd be x to the fourth. And then when I take the negative 5 times the 2, those act like pure numbers, so that would be a negative 10. And the property of multiplying like bases, and we need to write our polynomials in descending order for our final answers. I'll go ahead and zoom in on problem number 2, and we'll get started with it. Well, we have a negative 5x squared times 7x plus a negative 5x squared times 2x squared, and then we have a negative 5x squared times 8. Now, if you can go ahead and do this mentally in your head and go negative 5 times 7 would give me a negative 35, and an x to the first times x to the 7th would be x to the third. I don't have a problem with that, where you don't need to show this work right here, but if you can't do this correctly in your head, you need to do these steps so I can see what you're doing wrong and I can help you out. Now for the next one, the numbers operate as just numbers, so 2 times a negative 5 would be a negative 10, and then x squared times x squared would be x to the fourth. And it's 4 not because of 2 times 2, but because of 2 plus 2. And then the last one is a negative 5 times 8 would be a negative 40x squared. Now the next thing that we're asked to do is write these in descending order. Remember, descending order has to do with the highest degree polynomial, and that degree is determined by the exponent that belongs to the x. That leaves us a negative 10 x to the fourth minus 35 x to the third minus 40x squared, and that's your final answer for number 2. Now as we look at number 4, you can see that it's a little bit different from the previous problem in the fact that we have 2 variables, in other words 2 variable bases. Remember, there's an exponent of 1 there and an exponent of 1 there. And I'm going to take a little bit more of a shortcut where I'm not going to show everything, but I'm going to draw me arrows to help me understand what's taking place with monomial in front times the polynomial pieces on the inside of the parentheses. So 7 times a negative 3 is a negative 21. X to the first times x squared will give me x to the third. Remember, we add the exponents. Y to the first times y to the first will give me y squared. So that first term's been distributed to. Now I go to the second term. 7 times 2 will give me a positive 14. Then x to the first times x to the first will give me x squared. And then y to the first times y squared will give me y to the third. And now I need to take that outside monomial to this inside term. So 7 times a negative 3 again is a negative 21. And I have x to the first times x to the first is x squared. And then y to the first times y to the first will give me y squared. Now if I look here, I do not have any like terms at all, do I? if you look at your x's, this x has a x to the third, this x is x to the squared, this is x squared here, and you may think these two are alike, but they are not exactly the same when we look at the y's. So these are all terms that are different, and therefore I can't collect them or simplify this problem any more than it already is. So we'll go ahead, and that is the finished problem right there. Now we'll go ahead and move on to problem number 7. And you can see that it's very similar to problem number 1, except for the fact that we have basically kind of like two problems. We've got a monomial times a polynomial, and then another monomial times a polynomial. So the best thing to do here is to split this apart into two simpler problems, and then the result from this problem we add to the result from this problem, and we simplify our everything that way. Alright, so I'm going to distribute the 4 through there. So 4 times negative 3 will give me a negative 12. And then x squared times x to the first will give me x to the third. Remember, when we multiply like bases, we add their exponents. Now I will take 4 times 4 will give me a positive 16. And x squared times x squared will give me x to the fourth. And last of all here, I take 4 times 3 will give me a positive 12. And then the x squared really doesn't have anything to multiply, so it just moves forward. Okay. Now let's take this one. Negative 2 times 3 will give me a negative 6. Then x to the first times x to the third will give me x to the 1 plus 3, which would be 4. Now, a negative 2 times negative 5 will give me a positive 10. X to the first times x squared will give me x to the third. And then last of all, a negative 2 times a negative 2 is a positive 4. And then the x to the first comes forward, which will just give me an x. Now we'll go ahead and look at the common or like terms. Remember, a like term, we don't really care about the number in front. What we're looking at is the variable piece and the exponents to each variable or base. So if I look at x to the fourth, I've got a 16 x to the fourth minus 6x to the fourth. I will do my highest degree terms first, and so that little piece right there to this answer will give me 10x to the fourth. Now we'll do the x to the third, negative 12x to the third, and then I have a positive 10x to the third. Will give me a negative 2x to the third. So now I've done that piece, I've done that piece, I've done that piece, and I've done that piece. Now we look at the last little bit. Well, I don't have another x squared term, and I do not have another x to the first term, so those will just move forward. So my final answer will be 10x to the fourth minus 2x to the third plus 12x squared, and then the last term would be plus 4x to the first. So that is the final answer for number 7.